Goulden and Jackson formulated generating functions for irreducible characters, that is, irreducible character immanence. And I want to show you that formula that they came up with. Let's define gamma k of x, and I'm thinking of x as this n by n matrix of variables. So gamma k of x is going to be a sum of all permanents of k by k principal submatrices of x. So take a subset of cardinality k, use it as a row subset and a column subset, take the permanent of that. Sum of all these k by k permanents, where the row subset and the column subset is the same, is gamma k. And we'll define gamma of 0 to be 1 and gamma of k to be 0 if k is negative. Then using these polynomials gamma, we'll define a matrix C to be, so the ij, actually this depends on gamma, sorry, this depends on a partition too. So given a partition, we define C, which really depends on lambda, to be the matrix whose ij entry is gamma lambda I plus j minus I. And the theorem of Goulden and Jackson from 92 is that the chi lambda immanent of x, the generating function for the irreducible character chi lambda, is the projection of the determinant of C lambda onto the span of all monomials, all these permutation monomials. So by saying projection, I mean we're just going to take monomials of the form XEW and their coefficients. So we'll just throw out all the other monomials. So for example, if lambda equals 4211, then C is the matrix now this formula for the ij entry is actually simpler than it looks. So we're going to take gamma sub 4, gamma sub 2, gamma sub 1, gamma sub 1, and put that on the diagonal. So that's when I equals j, and so this is going to be a 0 here. So we just put the different parts of gamma on the diagonal. Well, gamma sub the different parts of lambda. And then if we go one above that diagonal, that's when the column is one greater than the row. So we just add 1 to the indices as we go to the right. And then if we go one more step to the right, we're 2 above the diagonal. So we basically take our diagonal entry here, gamma 4, and as we go to the right, we just increase the index by 1 each time. 4, 5, 6, 7. And then this 2, we go 2, 3, 4. And then to the left, we decrease it by 1. Gamma 1. Now gamma 1 goes to the left to become gamma 0. Gamma 0 is 1. Gamma negative 1 is 0. Again, we've got 1, gamma negative 1, gamma negative 2. They're both 0. So C equals this, and the 4211 irreducible character immanent of X equals the projection of determinant of C onto the immanent space. So we take the determinant of C, and then we'll get some polynomials which have monomials that don't have that form. And we throw them all away, and we just keep the ones that look like this. So it's a little bit cumbersome to do the example out exactly, so I'm not going to write it any further than this. But we take the determinant of that matrix and then throw away all the monomials that don't look like this, and that is the Goulden and Jackson formula. The end.